Okay, now leading diagonal element is nothing but it is it is the principal diagonal element. That is, this element is always called leading diagonal element. So we are going to sum it up. That is called capital D1. So to find D1, sum of the leading diagonal element, it is 2 plus 3, 2 plus 1 minus 3. The answer is 0. Now let us move to another formula, that is for D2. For D2 we have a formula, sum of the minus of the leading diagonal elements. So now here we are going to calculate what is the minus to find leading diagonal element. So to calculate minus we have another formula. I'll let you know. First we are going to calculate the minus only for the leading diagonal element. Let us see what is the minor for 2 first. So the minor for 2 first means you have to remove this row and columns, then you have to write the resultant element in a determinant symbol. Similarly, you need to find out the another value, that is 1. So now you need to calculate what is the minus for 1. Similarly, you need to calculate what is the minus for minus 3. So the intersection rows and columns should be removed. The resultant value should be written in the determinant, that is called minus. So that I have written here. Now you can see the first value, the determinant value, the second value and third value. As per the formula, sum of the minus of the leading diagonal elements means we have to sum it up. Okay, now the answer is here. After taking determinant, the answer is minus 5, 6, minus 6, minus 2, that is minus 13. This is D2. Now to find D3, our formula is determinant A. We know very well how to find determinant capital A. So to find the determinant capital A, first write all the elements in a determinant symbol, then take determinant. So by using determinant concept, I have found out the value for determinant minus 12, that is our D3. Now we have got all the values. Now our job is we have to substitute all these values in the characteristic equation, then just simplify it. To simplify it, I'm going to take synthetic division method. For in synthetic division method, just write all the coefficient values of this characteristic equation. Then by using synthetic concept, I just have calculated what is the values, that is cubic roots, that is 1 1 3 minus 4, that is my eigenvalues. Now I have calculated what is the eigenvalues. Okay, now for this eigenvalues I need to calculate what is the eigenvectors. So to find eigenvectors, there are some procedure that we need to follow. First one, write the given formula to find eigenvectors, that is capital A minus lambda I x is equal to 0, where x is nothing but it is small x1, x2, x3. Now we know what is capital A minus lambda I. That means capital A is your given matrix and lambda is your scalar value. You need to multiply your scalar value in unit matrix, then you will get minus lambda 0 0 0 lambda lambda 0 0 0 lambda. Then you have to subtract this value from the given matrix, capital A. Then the resultant value is 2 minus lambda 2 0 2 1 minus lambda 1 minus 7 2 minus 3 minus lambda. Then write the value of x here. Then we just because we have written all the values in matrix form, so I'm going to convert this 0 as 0 matrix. After converting all these things, first what is the eigenvectors for the first eigenvalues? When you substitute lambda is equal to 1 in this equation 1, then your value is 2 2 0 2 0 1 minus 7 2 minus 4, then the resultant values. Now from this I'm going to find out what is the eigenvectors by using cross ratio method. So here what you need to do, you need to verify whether you are having any repeated row values in the given matrix or not. if you are having the concept is, the thing is, you need to pick two different rows. Okay, for that you have to make sure that you are not having repeated rows. So here all the rows are different, so you may choose any two rows. So I have chosen from this these two, as I have given the tick mark. So there is a procedure to find eigenvectors by using cross ratio method. Here what you need to do, you have to write the coefficient value of x1, x2, x3 in the given order. Here start with the coefficient value of these two, then write the coefficient value of x1, then next, then repeat what is the first value at last also. This is the procedure. Remember, start with second value, that means x2 coefficient value, then x3 coefficient value, then x1 coefficient value, then repeat the first value as last also. So these two value as x1, these two as x2, these two as x3. Now write all these values as per the given format. Now you are going to calculate what is the determinant. So by calculating determinant, then you will get what is the x1 and its corresponding eigenvector, x2 and its corresponding eigenvector, x3 and its corresponding eigenvector, that you have to write in the given format. So that is our x1, that means eigenvector 1. Similarly, you need to find out eigenvectors for other two eigenvalues. So when you substitute lambda is equal to 3, that is our second eigenvalue, then the same procedure that you have to follow to find eigenvector 2, then you will get eigenvector 2. Similarly, you can find out eigenvector 3. So in this concept, I hope everyone have got a clear idea about how to find eigenvalues and eigenvectors. Okay, thank you so much. We will meet in next video.